It's the Saul Donahue Show with your host, Saul Donahue.
Math, what is this craze? First we had algebra, and then geometry, and calculus, and analytical geometry, and now solid analytical geometry with surfaces of revolution and quadric surfaces. Where is this leading us? Well, today we have two guests, Peter Ullman, famed economist at Princeton University, and Amir Epstein, holder of the Nobel Peace Prize for his work in mathematics. Our first guest today is Peter Ullman. Peter, what is this thing about this math?
Well, in math, such as this solid analytical geometry, we have things like cylinders and surfaces of revolution, well, for a surface of revolution, we might have something like this interesting figure.
Oh, let the viewer have a shot at that.
Oh, yeah, let's get the zoom in on that. You see, it's a paraboloid. It's just a parabola that's been spun around in a circular fashion. So it's a circular paraboloid. We use these a lot in economics at Princeton because it makes a nice bowl. You know, you can fill it with all sorts of, expensive economic goods. And aside from the surfaces of revolution, we also have cylinders, like this. We have the familiar right circular cylinder, but we have a new definition. We have a curve in a plane. In this case, the curve is a circle, and we also have a line that's not in the plane, and every line that's parallel to this line, but also intersects the curve, defines a cylinder. Notice that the line here is perpendicular to the plane, but it doesn't have to be. Then we would just get a tilted cylinder. Here we have a cylinder that's not familiar, because the curve isn't a circle anymore, but it's just a parabola. It doesn't even have to be a convex set. It can just be just any old curve. So we have a new kind of cylinder.
But wait, that's not the traditional definition we had in geometry.
No, it's not, Saul. So we have to be careful of that, because we have a new definition for an old concept, and that's often very confusing for our viewers. So we have to just be careful.
That's an interesting figure right there. What is that?
That's an elliptical cylinder, Saul. It's like a circular cylinder, but instead of being a circle, its base is an ellipse, so we call it an elliptical cylinder.
That makes sense.
Yeah, I thought it would, Saul.
Oh, that's interesting. If you look at that right, that could be a roof to a house.
Yes, it could, Saul, and that could be someone shaking out a carpet.
Wow, how practical.
See, so this math thing isn't so confusing. It's really very practical. It has all sorts of useful descriptions for everyday phenomena.
Thank you, Peter.
Well, nice meeting you, Saul.
Nice meeting you. This guest is Amir Epstein. Amir, what do you have to contribute to this strange world of mathematics?
Well, according to the book, in three-dimensional analytic geometry, the graph of a second-degree equation in x, y, and z is referred to as a quadric surface.
Z? Where did the z come from?
Well, in quadric surfaces, we add or subtract z squared over c squared to the original equation to get something that's graphed in 3 dimensions.
Ah, I'm beginning to understand.
Yeah, here, if you hold the book, maybe I can show you.
Sure.
Here we have the papers which I showed to the Nobel Prize Committee when they gave me the prize. Here we have x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. This is an ellipsoid, and that's the picture of one.
And all we did was add z squared over c squared.
Exactly. But wait, there's more. Here we have the equation of a hyperboloid of one sheet. It's x squared over a squared plus y squared over b squared minus z squared over c squared equals 1. It's called a hyperboloid of one sheet because all the points are connected as if it was one sheet.
Which means all the points on this curve are connected.
Exactly. And here we have what's called a hyperboloid of two sheets. The equation here is x squared over a squared minus y squared over b squared minus z squared over c squared equals 1. And here we have the drawing. It is two sheets, and therefore it's a hyperboloid of two sheets. Both of these are swung around the x-axis. 3 more. Here we have the equation of a cone. It's given by x squared over a squared plus y squared over b squared minus z squared over c squared equals 0.
That's almost the equation of a hyperboloid of one sheet, except that it's equal to 0 instead of 1.
You're a quick learner.
Thank you.
Now here we have what's called a hyperbolic paraboloid. And you notice how it's really ugly to graph. Here we have the equation, which is equal to y squared over a squared minus x squared over b squared is equal to cz.
That looks really ugly. Let's not have our viewers dwell on that.
No, we better not. Here we have the equation of a paraboloid. It's given by x squared over a squared plus y squared over b squared equals cz.
And all that is a parabola rotated around a set of axes.
Exactly. You caught on really fast.
Thank you, Mayor.
That's just about the entire thing.
Oh, but wait. You have a movie coming up, don't you?
Yes, I do. I think you have a clip of that, don't you?
Yes, we're about to see. It's called Having Excitement with Mathematics.
I don't think this needs any setting up, so let's take a look.
Okay. Interesting, but we'll be back right after these messages.
It's almost out. It's summer. The weather's getting hot. You're looking for that perfect party drink. That drink that, well, it goes with just about anything. Coors. Made of pure, fresh, Rocky Mountain spring water. Never bitter, just good beer.
The time where our audience can ask various questions to our guests. You, in the back.
Well, Mr. Peter Roman, what are the socioeconomic impacts of such a...
Well, I'm glad you asked that, because at the economics department at Princeton, we're working on a way that we can use surfaces of revolution as containers for liquid economic goods, such as petroleum. Like, well, take this paraboloid here. In 10 years, people could be buying oil in barrels that look like this. Now, of course, these are much less efficient than the cylindrical barrels, which are also much less efficient than using a cube to store the oil in. But then again, what the hell?
Sure. In the back, you have a question?
Yeah, I just wanted to say, all this math stuff, hell on earth and the like, well, I'm responsible for it. And then, well, there was just this message that's, well, it's been burning in my mind. I just had to get it out. So, well, worship me. Worship me. Get down on your knees and pray to Satan. I am Mephistopheles, the devil.
Okay. Call in right now. What's your name?
My name is Mr. Essie. I'd just like to say, for all of you viewers out there who don't start understanding this stuff, well, you know where you should be. That's all I have to say.
Thank you. Looks like we're all out of time. Make sure you tune in tomorrow when we talk about pregnant nuns and their priestly husbands.
This has been the Saul Donahue Show.
Yeah,
Okay.
that's good.